Hello, hello. Okay, let's get started. Let me share my screen. So for today's topic, I'm going to take around 30 minutes to explain and do some demonstration for the like uh, data collection and analysis, including some pre-processing for our data sets. And then we will go to the machine learning part, have a quick demonstration how to train those models in scikit-learn. And if you have any question, like feel free to post it on the chat. And later on, we will have around like 1 hour for the question and answer. So you can bring your questions or you can simply post it on the chat. And later you will be able to share your screen if you have any like technical or other questions. Is that okay? And we can get started. So for our assignment, basically we have around 4 steps. So the first step is to do the data collection. If you have no idea how to do the collection, so basically just the same as our what did we do in the lab session. So you are going to use your Mac or Raspberry Pi or Wi-Fi dongle with Windows machine to do the data collection. And if you just bought a Wi-Fi dongle for your Windows machine and you have no idea how to set it up, then you can have a look of this video. It will like it will show how install code in Word. Sorry. So basically, I have made a video on how to set up the like stuff in your Windows machine. And I will share this document later and send the link into our ad forum. So don't worry. And the recording will be available after this meeting. So for the data collection part, I think we will not have lots of trouble, but maybe we have some problem in here, like such as like how many data is sufficient. Right? This is frequently asked question. And what's next? And what, what like how many days? So those are the commonly asked questions. So for the first one, like how many data do we need? Then you can have a look of the marking rubric in here. So data collection, if you want to get an excellent grade, then you need to choose 2 different locations. and with 3 different days. Is that okay? So 2 different locations and 3 different days in here, which which means like, let's say Monday you go to the like library, and then because we need to have 3 different days and 2 different locations, right? Let's say I choose the main library and law library, and then uh, I can say like maybe like afternoon law library, and then like night I went to the main library. And maybe like we can repeat this one on Tuesday, and then we do the same one on the next week, or we can call it week 8, and maybe week 7, or doesn't really matter. So maybe we can choose 2 different weeks to do the collection, and something like this. Or you can also switch like the main library with the law library for the time. Like, so now you can see with this one, for the main library, I have both afternoon and night, which is looks better. Something like this. So, and you can do more. Is it okay? And yes, and another question is like, how about the channels? And this one is frequently asked in the ad forum. If you go to the forum, then you can find the answer. But now I'm going to tell you directly. So, so cover all the channels for 2.4 gigahertz, which means like 1 to 12 usually. Or if you can catch 13, then you can do it. So then you have another question, like if I'm using a MacBook, then I need to select the channels one by one manually, right? And we will have a script, or you can develop your own script to switch the channel that like automatically. Let me find the post I have sent. Mm, assignment. Yeah, this is a post. I posted on the ad forum. Then I will send it into the chat. If you are using a Mac, maybe this one will be helpful because we will automatically change the channel for you every 10 seconds. You can change the value and the channel number in here to fit your requirements. Is that okay? So you can have a look of this post. Maybe helpful for your data collection for your MacBook. And how many days? Like we said, we need at least 3 days. And then how can we prove our data is sufficient. Even you have like more than 3 days of data collection for two different locations, then you still need to prove it. You need to have a, for example, you can put a like a schedule in your report at first to show like how many days did you spend for data collection, and then in the machine learning part, you need to like plot a graph about the data volume in here. I remember we mentioned in here. So you need to have enough for training the machine learning models. So what does it mean? You need to plot a accuracy against the training volume. So you have a plot, and I remember I post this one as well in the ad forum. If you have a look, maybe I can share this one right now. Just give me a sec. I'll pull the question right now. Yeah. So in this post, to prove you have sufficient of data, you can and plot this kind of graph. So each curve is like each different legend and color is a different kind of model. As you can see in here, I have 6 different models in machine learning. And like because they are different models, so their requirement for the data volume is different. And for example, this one, this one, this one, you can see the accuracy is increasing, keep increasing, right? Until the 90K of data fit into the model. And it will decreasing if we add more data. So for this model, we will say maybe if 90K of data is sufficient, and the same idea for other models. So for this one, you can see basically it doesn't require lots of data, and we can say 10K of data is sufficient for this one. But you still need to plot this kind of graph to prove it. Is that okay? So for example, you have these 3 models trained, these 3, and then you can say I have 20K of data is sufficient, right? So I will also include this post into the document, and I will also send it into the chat. Then I think that's all. Just let me know if you have any doubts about this one.
Yes, excuse me. Could you hear me?
Yes.
I just filed a script in ED so it focuses on the channel 16711.
Mm-hmm.
When I use the Kelly, could I use the same channels as our script?
This one?
No, not this one.
What's the number of the?
It's just you say before, you send the chat box before as the max script. The max script.
Max square.
Yeah, just as you mentioned in 5 minutes ago. MacBook script. Yeah.
MacBook. Uh, I remember. Like, are you have some trouble on the channel 1 or something?
Hash 2061.
2061, right? 261.
Yeah.
This one. Yeah.
Yeah, I just filed this script. Sorry.
Yeah. I know. So
just
you have this trouble, right?
no, I just want to ask, could I use the like this script 167 as our 3 channels, and we use it for the Linux.
Do you mean like can you use only three channels in
Yeah,
here?
yeah, yeah, yeah,
Yeah, so according to the specification, we need to cover all the channels, which means all 12 channels or 13 channels in here. So we are going to collect as much data as you can, covering all the channels, which means not only three channels. So you may need to do some modification in here. Like you can say, because you can usually select from channel 1 to 13, right? So
yeah,
you put all the numbers in here. But like in general, we will say most of the data will occur in these three channels, right? Because these three are non-overlapping channels.
yeah.
So most of the access points will lie in these three channels, and just a few, maybe you can barely see one channel lying in the other channels, but never mind, we just cover all the channels.
Okay. Thank you. I know it. Thank you.
Okay, no problem. So we need to cover all the channels again, all the channels from so because some of the like equipment cannot cover the channel 12 and 13. So just have a check of your device and just try to cover all the channels if possible. Even like you can only scan from channel 1 to 11, then just cover 1 to 11. And yeah, so for the step one data collection, I think that's all we have. And just let me know if you have any trouble. And another question is 5 minutes of data collection per channel. So I couldn't say it's enough or not, but you can prove it by yourself. Like how to prove you have sufficient of data. So firstly, you you go there like 3 days for two different locations, and then you need to plot when you go to the step 4, which is like machine learning, step 3, and then you will have this kind of graph to show you have sufficient of data. So usually we don't need that much of data, but I couldn't tell you what is the exactly number do we need to train your model to have enough sufficient like to have sufficient of like data to have the high accuracy. So you need to prove it by yourself. And the step 2, processing the data. So in the step 2, we have a lot of tasks in here. I'm not going to cover them all, but I will give you a taste of how are we going to do it. So firstly, we need to do the like data processing, like by simply apply a filter in Wireshark. So this is my collection. I went to the main library and then collected channel 6 data. And this is my Wireshark. Maybe firstly, I can simply put a FC retry equal to 1, which means retransmission data. And you can see it's loading. It takes time if you have a larger data set. And then you can see this is all the retransmitted data. And in here, we can see the count in here. It says I have around 200K of data, and around 2% of data is retransmitted. And that's a reasonable number. Then we can see the details inside. Like maybe you can click one of the packets and then see like what is the uh this kind of what is the frame type. This is a data frame, and maybe another one. This is a probe frame, probe response, right? So you can see there are different type of frames. And then the channels, some are using 5 and some are using 6. And the duration and data rate and etc. You can have a look of the information inside. And of course, the most important one is the then you just put it into the column in here. So maybe your Wireshark looks different in here, like mine. So in here, I add lots of different columns. So you can choose your own and make your own output in here. So I put a summary in here that I think this kind of features could be helpful. So signal strength, data rates, channel utilization. This one you cannot export directly, but you need to calculate by yourself later. And the retry flags, because we are going to use the like machine learning model to train the prediction model for the retry, right? So we must have this one. This one is very important. And packet size might impact because if we have larger packets, we might have higher uh, probability on the retransmission. And the other stuff you can have a check by yourself. And then what's next? After I apply them as a column, so basically I select the packets and apply as a column like this, right? So I will add a new column in here. So why am I going to add lots of columns here? Because I am going to export this file as a CSV file. So we can use it for later usage. So in here, because it's in Wireshark, but our Python program is not going to, not able to read this file, right? So we are going to export as a CSV file. So just export as a CSV file, and then call any name you want and save. And then you will have this kind of CSV file. This one. So it will become a CSV file. Then we can use to train our data and do some like processing by ourselves. So how can we do after this? Like maybe you can directly do the signal processing in the like Excel, but I prefer to do this one in pandas. So for further processing via pandas, and the code in here is about the pandas, how to use the pandas to like read the CSV file. So I upload my file into my Google Drive, and now I'm running a Google Jupyter, Google like Colab Jupyter Notebook. And then this is how it works. So it will firstly read the data frame from my Google Drive, and then I would like to show some basic information for my CSV file. It will include like 11 different columns. And then I like also print some statistics for those. Maybe not very useful for this chat. Let's skip this one, but maybe this one is useful, like the retry, right? We are going to check like how many retransmission packets like we did in the Wireshark. So this is the output from Wireshark, right? You can see it's exactly the same. And then we can start processing with like our Python program. For example, we can, because it's a text value in the table, if you check, like let's bring the data frame in here, you can see just a table in here. And the retry column is frame is not being retransmitted or being retransmitted. So we can simply replace this one with a function, apply function. So we can change the value in here, not being retransmitted, then we call it 0. And if it is being retransmitted, then we call it 1. So let's see this again. After I run this apply function. So I replace the long text with the simple digits 0 and 1, right? And then we can check this one again. So with number 0 on retry, which means it doesn't reach, they haven't been retransmitted, then we have this much of rows, and this is being retransmitted. We have like 3000, which is correct, like this one. So this is a very simple like data pre-processing based on pandas. So why are we going to do all those tasks? Because we are going to put those stuff into the machine learning model. but the machine learning model is not able to read the text in here. So we need to convert them all into like integer or float numbers. Let's say, so I'm going to do the stuff uh, step by step. And next one is to show the distribution of retry. So I'm just wondering, like I have 3,000 of packets which has been retransmitted. So who are they? Is it belong to any access points? So I need to have a check like this. So I plot a graph. So there are different access points. So basically iPhone and Galaxy and Uniwide. So you can see the like volume for crossing different access points. But this one is just a draft. So maybe you need to polish a little bit to make it nice and beautiful. But that's the idea. So, and what's next? Next is maybe instead of showing a plot like this, you can also show a table like this. So what is the proportional? Like let's say, I know Uniwide may have some retransmission, but what is the percentage of the packet has been retransmitted for Uniwide? Then with this table, I can see, it's around, I don't know, it barely happened, right? So it's 0.008% for Uniwide has been retransmitted. So you can see more insight with this kind of data processing tools. And then what's next is we are going to have a look of all the columns, because if you had a check of the data frame we have, it's like a normal table, uh, like what is the destination and what is the source is just some text, right? Text. We need to convert those tags with some integer or index to replace them, because we are going to put them into machine learning model. We need to transform this kind of data. Let's say, like this one, US will guest. We need to give it a number to specify. Uh, let's say we can give it number one. So when we say SSID number one, we can corresponding to this SSID USW guest. So the machine learning can only recognize the digits instead of text. So we need to do some tokenization in here. And this is the code I'm going to use it. It's pretty simple and straightforward. Basically, I put every single column into this fit transform function. Then you can see, and now it becomes all like integers in my table. So the source 316, it must represent one of the like source IP address or MAC address in here. So usually this is a MAC address. So it corresponding a MAC address at the back, like index. So for the machine learning model, you will say the column 1, 2, and 3, 4. The destination is the same destination, but it doesn't care like what exactly it is. You just need to know it's the same one. So in the future prediction, you can say if we are going to this destination, then we will have this kind of probability of the retransmission. So in here, we call it tokenization. So this is very simple steps on the pre-processing on the machine learning. So basically, you can copy the code. I will share this code into the ad forum, and this recording will be available later after this help session. And you can play around with this one. And of course, how about the next step? Next step is I'm going to train all the uh, three different models, KNN, random forest, and SVM. As you can see, not much thing we need to do. We just import all the like all the models from the library, and then we split the trained data set into like A to 2, So 80% of the data will be train the model, and 20% of data will be test the accuracy of the model. And then this is just very standard code. You can easily find it online. And you can also have a look of my code. I will share this one later. Then this is the output because it takes time. I'm not going to run it again right now. But you can see like the accuracy across in different, um, three different models is around like 89 or 99%. And we can also plot the accuracy against the data volume. So you can see the SVM, we does not require a lot of data to have the high accuracy. And for the KNN and random forest, then we can see a totally different story. In here with the KNN, it's definitely not sufficient to train this model for now. So for the KNN model, I would say maybe I need to collect 2 or 3 more sessions to see what is the curve. So maybe I add one more session, it will go up or if it goes down, I have no idea. So I need to have a check this kind of curve, then you know you don't have sufficient of data for this model. But for those two, I would say like it's quite sufficient for the like SVM and random forest because they are a very simple algorithm. So for the random forest, it's kind of decision tree. So I think it doesn't require lots of data to train the model. But the KNN is kind of clustering. Then you might need to have lots of data to feed this one. So this is how it works. Is that okay? And I will share all the codes, including how I generate this kind of graph to you. So you don't need to worry too much of like you have no idea of how machine learning works. But basically, if you spend like 1 or 2 hours on reading those code and documents of scikit-learn, then you will have no trouble on the machine learning part. So I would say like for this assignment, it's not about machine learning. It's more about data collection and data processing. And just to notice here, like in here, I did not do a lot of job in the data pre-processing. I simply just convert them into like the token in here, but I did not do a lot of like pre-processing. For example, I just simply replace the retry with 0 and 1, but actually we should do more. For example, you can calculate what is the latency for each access point in this table. Like we can find the maybe I can go to this one. We can see we have some acknowledgement here, right? We need to know what is this acknowledging for. So probably this one. I need to have a check of the destination is to the BC, so not this one. Not sure which one it is because sometimes we cannot find the corresponding packets for the acknowledgement. That's pretty normal. And we need to find them more if possible. For this one, maybe not, but we can skip to another one and try to calculate what is the latency for those acknowledging packets. So we can calculate what is the delay for each single access point. So once you have sufficient of data, then you will be able to with corresponding data or beacon frames. Is that okay? So you can calculate the latency with your own program by looking at the table. And I remember I share a how to calculate the latency in the ad forum. Yes. Uh, this is the post. So in this post, I explain how to calculate the latency because the ACK frame does not include the source address and the frame and the sequence number as well, because the acknowledgement frame uh, to just to have higher efficiency, it will omit these two information, which means you need to have a guess in this part because we are sniffing. We are not a part of the uh, network. So we have no idea what this like acknowledgement for. So we need to have a guess by ourselves as a sniffer. But we can simply write a program to do this job for us. And in this post, I have a clear demonstration of how to guess who, what is the corresponding packet for this acknowledgement packets I posted in here. Maybe you can have a check. And that's the machine learning and pre-processing part. I hope it will be helpful for you. And just let me know if you have any trouble with this.
Yes, excuse me. Could you hear me?
Yes?
I have a questions. It's about I find that we have one a models made by machine learning. So if we just to make every channel as a model or just get it together in one model.
Uh, what do you mean?
Just one channel and use these channels as one
Uh,
model as added together. Uh,
I see. I know what you mean. Like, so you are saying because in my Wireshark, this is only channel 6, right?
yeah,
So I do it, and my output is like, let's say, my final output is this. And should we do like repeat them like for 12 or 13 times
yeah.
for like for those? No, actually no. So because what are you going to do first in here? Because I have just did a very simple data collection here, right?
Yeah.
Let's say this is your output and the channel is 6. So what are you going to do? You are going to export a lot of CSV file and then merge them together. So you will have from channel 1 to 13 in this table.
So we just add it together to make one module. Is it correct?
Yes. Yes, you can put it into the one table, and but you may have some trouble on time here because it will
Yeah,
start from 0, right? And
yeah.
end by the end of value. So maybe you need to figure out a way. Uh, so let's say if you want to do some calculation for the latency at first, maybe you do it in a separate CSV file. So you can add a new column called latency. Then after you calculate the latency in here, then you can merge them together because the time in here is useless
Okay.
besides the latency. Or maybe you have more usage for the time, but just be aware of that. The time will like mix together if you merge different CSV file.
All right. And the other questions is because we collect it in different states, uh different
Latency?
area. Yeah.
Yeah.
So if we collect in different days, different times, so we just make it every time there's a model, I just add it together. Because we know sometime on Monday, people are crowded, but on
Yeah.
Sunday, people are
Yes.
don't have
Yes.
to go to school.
So
So
uh
yeah,
yes, yeah, so it's also the same question for the let's say for the data collection, right? Uh,
yeah,
I recommend is we can have a maybe we can put like something like this in here. Let's say this is my collection. I
yeah,
and then I will have like multiple one, right?
yeah,
Okay, this I call maybe I assume this is channel 1.
yeah.
Channel 1, and then I will have a lot of this kind of stuff in my folder. And what I'm going to do is maybe when you export as a CSV file, you also specify this kind of like very useful information inside the CSV file. let's say now I'm going to merge them together. Like this is one of my CSV file. And then now I'm trying to merge all the CSV file together to train my model. What I'm going to do is I can add one more column in here. And then I can say, for this one is for the, I also can specify the location, like, and then I call it main library, right?
Oh.
I create my own label in here, right? And some of them maybe are law library. Let's say just pretend I have multiple file. I'm trying to merge them together, and
Mm,
those are from the new file. Then I know it's from this one is from the law, right?
mm, mm.
Law library. Then I can say this from law. Then when I merge them, then I create my own label manually. Then I will know those column are from the law library from this file, and those from the main library from this file. And I also can specify the real time, like in here, like what's the daytime in here. Let's say 0 on like 15 o'clock, like this. I can I can type the time with my hand, right? So
Yes.
I can also specify the time, or I can call like even I can create a weather, right? Maybe
Yeah.
weather may affect, but probably not for indoor environment. So it's sunny day. So you can create your own label besides the Wireshark. So you can create more stuff by yourself. When you do the collection, you can have more information. And of course, and the other one maybe it could be the latency. And also maybe in the future, you can also calculate the channel utilization, right? Like, is it busy in for this channel? This is channel one. I'm not pretty sure like how many channel for the channel, how many access point for the channel six or channel one. So is it a very busy channel or not? Maybe you can give it a value. Maybe let's say I can say it's like 15 different channels at the same 15 different access point at the same channel. Or like sometimes you can see that value is change during the time because like some people are creating their own hotspots with this channel. And let's say this is like in a very busy time afternoon, and this is like in the midnight. Maybe we just have 4 or 5 different channel at the same channel, 4 or 5 different access point in this at the same channel, and maybe the latency can also change. Is that okay?
Oh, I know. So if we add all the CSV together, if one CSV is maybe 200,000, and we add all the information together, maybe we can get a very large CSV, like hundreds of million of line, is it?
Yeah. Yeah, so you can create a lot of new columns by yourself. And when you merge them, just be aware of that. You need to give them a label so you can specify them easily. Like,
So yeah,
yeah,
so just input these hundreds of millions of data in the module and training one modules to get a
yeah,
result.
yes, exactly.
Okay, thank you. I know it now.
Yeah. So finally, like before you come to this step, you need to have a merge CSV file, right? Otherwise, it will be useless. So in
Well,
here, my collection is very simple. I just go to the main library and do the collection for channel six, and that's all. So I didn't split them into different location or different times. So for this graph, maybe you can have more complex one. You can group by different times, group by different locations, group by different, I don't know. You can have your own idea to show, to see why and what is distribution of the retry. Like I can see like some iPhone may have higher retransmission, but why? I need to figure out what is the reason to make sense. So for this one, it's more about analysis and the data processing. So you need to have some insight of your data you have collected instead of just simply like put them into machine learning model and say, I have very high accuracy. So I would think maybe it's not a good way to get a high, like if you want to get a like high distinction for the assignment, probably it's not a good way to do it. Just simply put it into the machine learning model. You need to have some like insights of your data set and just write it out in your report. And because we all know, like to do this kind of training is very simple. Just maybe run the code. Maybe all you need to do is just copy my code and change the directory, and then it will work. And you will get a very high accuracy model. But so what? It doesn't really help you to understand this assignment and help you to design the protocol in the next step. So I strongly recommend to play around with your data set and also just record all the stuff you have done for this assignment. So just to show your efforts to your uh, tutor or your like when whoever will mark your assignment. So let them see how many times did you spend and how many efforts did you spend on this assignment. So it will definitely help you to get a higher marks. So for the data collection, basically, I recommend to have around like 4 or 5 hours at first to see if you have sufficient of data like this. So for this one, not sufficient. I take around 1 hour to do the collection, not sufficient. And you can have more. And then you can spend more time on the part, this, uh, this part, protocol enhancement design. So you can go through some uh, uh, lecture slides or papers and different maybe you can also ask ChatGPT give you some idea, but you need to refer to some like official documents. Let's say you can refer to the textbook or you can refer to a paper to about your enhancement design. So just be aware of that. You need to read lots of documents in this part and write down your report. And for the machine learning, I don't think we are going to spend a lot of time. Basically, you can use the code I'm providing. And the key is the features. So you may spend lots of time by creating lots of features that could be helpful for you. So in here, you can create the features like latency, channel authorization, and maybe not weather, but the daytime and location, I think is must have. And then you will put it into your machine learning model. Maybe you can delete some of them to see if the accuracy is changing. You can do some simple comparison. Let's say I remove the packet length and see if my accuracy drop down or goes up. I'm not pretty sure, but you can have a check and then write it out in your report. So you can see I am tuning some I'm tuning my machine learning model to have higher accuracy than normal. And that's what I did. Is that okay? And
Yes.
that's all for the assignment for today. And next week, we will have one more session on the help session for the assignment. Maybe I'm not going to dive into the protocol enhancement because it's all about reading and understanding your own data sets. So uh, for this one, you can post your thoughts in the ad forum and ask our lecturer to help or give you some more feedback on your protocol. You can say, my protocol is like this, step 1, 2, 3. And then do you think is that okay? Or do you have any feedbacks? And ask for help from our tutor and the lecturer. When and mostly it's about the machine learning and the performance analysis. Maybe you may spend lots of time on this part, I would say, and this part. Just let me know if you have any trouble and would like me to spend more time on this part. And I will give all the time to you right now. So we still have 1 hour. Feel free to stay here if you have any question. And all this recording will be uploaded into the ad forum later.
Okay, excuse me.
Yep, yep,
And I want to ask about the sports. I just want to ask about the area we collect the spot on the map. Oh, sometimes we can collect more retreat pockets uh,
yep,
in all pockets, such as in main library, we collect like 1.9%, just as
yep.
usual. So some area we collect like 10%, some area like 1%, some area we collect 5%. So
Yeah,
which area we collect percent is more sufficient for
reasonable.
our text? Yeah, yeah, more
Okay.
sufficient for our text.
This is very interesting topic in here. Yeah, you can see like as you say, you have variety on the retransmission rate in
Yeah.
different locations. Then this is very interesting. So I recommend write it out in your report. This is very helpful for the like protocol design later. So you can say I took a picture and put in your report, and I say this area the retransmission rate at this time is how many percent? 5%. But afternoon it dropped to 2%, and I changed to another area in the same building, but this part the retransmission rate is much higher. Then you can try to explain why. So we couldn't say like in here in library ground floor, I get 1.9%. Doesn't mean you need to have the same result as mine because the time and environment and the location change. So you can definitely have different number in here. So I'm not going to say 2% is a standard value. It really depends on the location and time and your device as well. So
I just to want to mention that I just to go to many place to collect the data. So I
yeah,
just want to use a few place in next week because I can't handle too many area in the same week. So I have the maybe four place, but they have
yeah.
different percentage of this rate.
Mm.
So with that, the highest percentage area as I collect next week, or just select the low percentage for
Mm.
I select next week.
So why don't you use them all? And if you can use them all, you can use them all. So in the description of our assignment document, so it doesn't have any limitation on the how many data can you use. We say at least two, but maybe you can have four different locations and 5 different days, up to you. So I reckon maybe for more like different location and different days, you may have lower accuracy, but that's okay. So what are we going to ask you to do is not to have a very high accuracy model in part three. So don't worry too much about this part. The evaluation, we just want you to know how can we do it and why this is useful and just to test your ability on this part, but not asking you to have very high accuracy. Even you get like 99.9%, I would say maybe it will not be very helpful for you to get uh, high marks in this part. So we need to have like clear examples of model usage and detailed analysis, right? So that's accuracy itself much,
Okay.
and don't worry too much about the digits in here display. But it's a good news that you have the variety on the retransmission rate. So maybe you can get more interesting results.
Okay, thank you. I know how to do next week.
Hmm. You're welcome. And we need to collect signal strength noise level. if my data is missing those parameters, can I still use the data? Yes. So we have a question in here. Do we need to collect signal strengths? Uh, so for the signal strengths, I think everyone can get it. So it will, I think it could be a very helpful for your prediction, yes. But noise level and signal to noise ratio, so we may not need it because it might not be helpful, but if you can get it, maybe you can include it in your data set. But I don't think this will affect a lot for your assignment submission. So don't worry too much if you cannot get it. But if you can get it, maybe it will be helpful for your assignment, I would say, because the noise level can help us to evaluate the surroundings. And if you cannot get the noise level, you can like calculate the channel utilization as well as the uh, data rate to evaluate what is the noise in the surrounding areas. So it's still okay. And the Kali have no signal strength. Mm, I see. For the aerodom NG, sometimes will not give us the signal strength. That's I saw this one before. Uh, Maybe you can have a quick test if the signal strength is useful or not, or you can use the Wireshark in Kali, Windows machine running the virtual. You can still run the Wireshark to do the collection. Oh, I see. And Wireshark have signal with no noise level, and then send off. I I see. So if maybe you need to have a test if the noise level useful or signal strength useful in the features. Maybe do a very quick comparison. Maybe you can have them both. You do the arrow dump and you do the Wireshark in one location and one time. Maybe just have a quick demonstration on the features comparison, and that would be very helpful. And next one, for the clarification, we need to merge all data collected from different locations and times into one set file to train the model, right? Thank you. Yeah. So in my opinion, you can merge different trace file into one with some manually labeled stuff like what is the location, what is the date time, and what is maybe no value. Delete. Maybe latency and channel utilization as well. So you can create those columns and merge them together. So it's not the only way you do this one. So maybe you don't want to do it in here. You can do it in your Python code. So, but I think this one is maybe easier. You can still do this one in here. Like when you load the data frames in your Python code into your notebook, then you can merge different data frames into one easily. But I'm just showing a easiest way and straightforward way to do this one. Maybe you want to merge them when you do the training. But anyway, we need to merge them before. Okay, what's next? And if you want to share your screen, you can also feel free to do it. I I will give you the permission on sharing your screen. If you have any like technical problem, feel free to share your screen. Okay. I found that except for channel 1, 6, from other channel is not much. Yes, definitely. If you have any uh channel analysis tools in your computer, like for example, I'm going to show a demo, very demo on the channel authorization analyzer. Maybe we can use this one. So you may have this kind of analyzer in your mobile phone. Then you can see most of the APs are those three channels. It's a like very simple concept on our lecture. It is because of the overlapping, right? The channel 1 will not overlap with channel 6. So with the access point in channel 1, it will not create any interference with channel 6. So that's the reason why those three channels are the most popular channels. So they are trying to avoid the channel overlapping with this kind of distribution. So you can barely see the channels live on the channel 2 or 3 and channel 9 and 8. That's pretty normal. So when you do the collection, maybe I think you can spend more time on sniffing the channel 1, 6, and 11. And for other channels, you can still do some sniffing, but maybe less time on that. So in your question, like, is it okay? That's definitely okay because we already know that. For other channels, we don't have much data. Where can we watch the recording? I'm going to put the recording in this link, uh, in here. So maybe I will do some modification on this post and send all the recording maybe just after this one. I will send this post to you. So for the recording, you can find it into the ad forum. And yeah, maybe I will stop the screen sharing and recording right now, so you can share your screen if you want, and we can have faster processing time for the recording as well. Just let me know if you have any question.